This video is about side marker light module.
Yeah, look what's arrived. 10k resistors. So now we can start doing all this shiz. We've got 5-pin relay, miniature relay, some transistors, 100k resistors, 10k resistors. Sorry, not 100k. They are 1k. And we've got some 100 UF, so microfarad capacitors. These are radial capacitors, electrolytic, and a bit of perf board. So I'll take you through that as well. I've got some diodes. They are way overkill. They're 6 amp, but I bought a strip of these anyway, so why bother to buy some small ones? We can just open out 2 of the holes and solder that in. It'll do the same job. So yeah, right, let's get making. Right, this is the first test. Got power supply feeding it in, ground and positive to the top of the lamp. This will be replaced with a relay. So all of these leads are positive. So you turn the light on, it comes on. Turn the indicators on, which I'll simulate by pushing there. You see it turns on. So now we just need to put all this on the circuit board. So a quick plan, I was going to make 2 boards and put one either side of the car. So one would be right next to the marker light near the passenger door and one near the driver's door. But I'm thinking now, if I've got to run a wire for like signal, because I'll have to get a signal wire from the indicator to each side, I could put both relays and do 2 identical boards but sort of Siamese. So we'll have a think. So that's one half of the board layout's done, but we're using these massive diodes because I ordered a 25 pack, which will be fine, but that means we've got to space the board further out, which means I'm not going to fit a Siamese board on one of these, so I am going to have to do 2 and then just wire them back to back. Never mind anyway. So one of the first things we've got to do before we mount some of our components is cut the traces on this strip board. So as you can see there, each row is conjoined, but where we've got some of these components crossing over, we've got to cut a strip behind where the relay is going to sit, cut a strip there, cut a strip here, cut a strip here as well, and there. So we need to break those first before we start soldering. Right, so basically all you have to do is just get a Stanley knife, try and cut along the copper tracks, and then pick at it with the end of the knife. Just try and get it down to the fiberglass board to break those runs. Look at that. Last piece of the puzzle. Solder that up. Alright guys, so here's the finished module. Basically red with black stripe, power in, black is ground, red with a blue stripe is output, red with white stripe, indicator, and blue with a red stripe is side lights. So I'll plug it in and I'll show you what's going on. Didn't do too badly, I don't think. Working it all out on this strip board. I've had to break the tracks in a couple of places and then put a jumper just there. So I'll also take you through the root of it all as well, for those that are interested. Right then guys, so I'm just going to take you through the circuit. We've got a 12 volt feed coming through this transistor, which is on the bottom of the coil of this relay. Normally open and normally closed contacts. So 12 volts coming into the coil and also into pin 30, or what would conventionally be pin 30 on an automotive relay. So that's your in, and that's normally open. So as soon as you put power to that coil, it closes and feeds our side marker light, which is 5 LEDs. or in this case 6. So they go to ground. Okay. Now this comes in. It can't pass through that transistor until the transistor has a voltage applied to the base, which is this part here. It's kind of like a 3-pin relay. Think of it as a 3-pin relay. So the side lights give a signal through here. It comes through here, and it also feeds this transistor. It feeds through here, comes through a diode, which is basically an electronic one-way valve. Comes through here and feeds this. So the side lights feed that and allow that transistor to get that relay to go to ground, which is what we've simulated here, just by putting a crocodile clip on that wire. That is side lights. Okay, now the other thing is, so that's going to ground. It comes this way. Now it can't feed that way because there's another diode, so it can't feed into the indicator circuit. It can only go this way, and it can only go around here. So it feeds into this transistor, but this transistor can't go to ground because the indicators haven't been selected as such. There's no voltage coming into the indicator to close that transistor. So the only way it can go is here. So you come onto a different situation where the voltage is taken off the side lights and the indicator gets put on, which is this one, and it comes on and off. That's because that is not getting any voltage from the side lights, so that doesn't open it, but the indicator voltage itself, the pulse, is opening it through here. So it can't go up there because of the diode. It comes along, tick tock, opens and closes that coil. It can also go this way, which puts the side lights to ground. But because the side lights haven't got any voltage coming through, it doesn't matter. So then what happens is, if we try and, hang on a minute, you put the side lights on and you put the indicators on. The first indicator charges up the capacitor. It doesn't actually flash the LED, it turns it off. You see, that pulses, and then it stays down, and then after the capacitor discharges it comes back up. So what's happening there is the side lights are feeding this to come on, but when the indicators are pulsing, it wants to put this on, but it's already on, and it also comes this way and it puts the side lights to ground. So instead of the side lights feeding this transistor, the side lights go to ground. The indicator is powering this, and it's also charging the capacitor. And when the indicators let off of their pulse, this capacitor is keeping this transistor closed, keeping the side lights to ground for a couple of seconds, so that when the indicator comes onto the next pulse, the lights are still off, and then it comes up here again, boom, boom, and closes this relay. So that's how it works, and I'll give you another demonstration of it. Just put this on here for the time being. There you go, just flicking the wire on there, and then it will come back on.